Hello, everyone. Hello, AJL community. Thank you for letting us present Vodafone's Edge innovation, InstantX, shaping the future of telco. I am Luis Alfredo, the technical product owner of the InstantX project. And my colleague here, Daniel, is our connected mobility solution architect. Here our contact in case you want to collaborate with us. So InstantX is a Vodafone initiative launched in partnership with LF in 2024. Certain components of Vodafone Step Enterprise Platform as a Service has been made open source through this project. That means Vodafone is running similar variant of InstantX powered by our network. The project is designed to ensure the secure and reliable exchange and distribution of data, enabling real-time communication between users and devices with the cloud within a specific geographic area. This is important, geographic area. This is how we are distributing messages. InstantX follows the European Telecommunication Standards Institute multi-access edge computing architecture principles called XCMEC. Within the LF framework, InstantX is located on the service provider edge side. It serves as an important connection between applications and infrastructure. This role enables InstantX to manage data flow and enhance connectivity at the edge. About the architecture, the system uses asynchronous publish and subscribe communication pattern where each message is tagged with a specific location that allows subscribers to set their subscription area and adjust the radius for required communication. That means that you can subscribe to a small or big area in case of the context and your interest. InstantX have different interfaces that interact with the environment, including MQTT broker for lightweight communication, AMQP client for platform-to-platform communications, and HTTP for web communication, mainly for texting purpose. We use encoded messages that represented as binary streams to decrease the amount of exchanged traffic. And finally, InstantX is using mainly ETSI standard messages, but we are open to extend the compatibility to other protocols and specifications. Okay, InstantX enables real-time data exchange and distribution between users or devices and the cloud within defined a geographic area by using GeoHash. This is the technology that we are using to separate and distribute the messages. Since InstantX follows MEC architecture principles, it processes data closer where it is generated, minimizing the distance data needs to travel to centralized data centers. This increases efficiency and accelerates data processing. InstantX is built to support applications that require low latency and high reliability via 5G networks. InstantX also provides offline data processing and self-learning capabilities, enabling additional analytics and value extraction from the collected data. So this key feature can be applied across various industries and use cases. The project is under construction right now, so we have developed it partially. So this is the current status of InstantX. We have implemented GeoHash messages distribution, dashboard to show metrics, message transformation and encoding. As I mentioned, it is currently using ETSI standard denim as a first message type. We also have a human-oriented HTTP API available for testing. And at this stage, we are almost finished with the vehicle-to-cloud POC in collaboration with AJL as a starting point for further explore features we can develop together. Only a few pieces of documentation and generation of visual content is remaining, okay, to complete the entire POC. So looking ahead, we plan to create a dedicated InstantX web page, as every open source project can have, with a forum to request or ideas. Improve the documentation by being part of OpenSF certification or budget plan. We will enable data storage with machine learning capabilities to continue integrating other messages type and a specification based on open source community needs. So we are open to leverage new possibilities, new ways to follow. Okay, InstantX and automotive-grade Linux collaboration. The collaboration between InstantX and project and automotive-grade Linux is key initiative under the Linux Foundation for us to engage with the community. This collaboration aims not only to expand the versatility of AJL, but also to support ongoing development of the InstantX project. Importantly, it increased a closer collaboration between Vodafone and AJL members, such as car manufacturers and technology companies, improving the overall ecosystem and driving innovation in connected vehicle technologies. So here you have a representation of the vehicle-to-cloud POC. Our initial collaboration has focused on integrating the Covenza VSS vehicle speed data to establish the complete workflow first. This integration required converting data from VSS to ETSI format to reduce the time needed to complete the POC. So we decided to go to this way. The open source community may request that VSS to be included as a core specification along ETSI. So this is a possibility. And finally, the data is presented on a dashboard and other devices such as a car can subscribe to these messages. You can see it represented here. Okay, so this could be a car. This could be another car using AJL, and we are sharing information using MQTT interface that AJL have, and is using a -Q MQTT broker that we have running on InstantX. Then we proceed to send internal using Kafka, transformation using NiFi, VSS to ETSI transformation, and then telemetry goes to Prometheus Grafana, and by this way, an external actor can see the dashboard here, and yes, we are basically exchanging information. Okay, so demo time. I'm going to be quick, okay? So getting started with the project is simple. You can run it locally using Docker or deploy it wherever you need. Okay, let me go to the demo quickly. So here you have, one moment. Let me move this here. Here you have InstantX, the InstantX code. Okay, one moment because I need to move everything. Oh my God, sorry. Okay, left side. And this should be on the right side, sorry. Okay, here. So in the left side, you have the HTTP interface, okay? And we are just going to send a message. Okay, that message is going to be published in a certain geohash location with a public publicity. Okay, so the message itself is the NAM protocol. So this is ETSI message, and is representing a wrong way driver. So by using ETSI messages, we are not only using the context of the car. We are using biggest context, using the location around this specific geohash, okay? So the message was sent, okay? And we should see it here. Sorry, because was disconnected. So let me go send another message. Okay, and finally, at the right side, you should see encode message. Okay, we are reducing the weight of the message by encoding in the correct format, okay? And you can see this here, the information. So this represents the car. It could represent another car or maybe another type of integration. And that's it. And finally, we have here, one moment, the geohash representation. Okay, this is the geohash representation, represented more or less this location, okay? We can move to another location if needed and send message to the specific location. And finally, everything is going to be seen in this dashboard. This is a quite simple dashboard. And that's all. Thank you very much for your attention. If you have any question, we are happy to discuss, okay? Thank you.